we're looking at common factors of polynomials today. And we did this before. Find the greatest common factor of each pair. 36 and 48. We did this before with numbers. You should be able to find the greatest common factor of those. So sometimes we can just look at the numbers and know that the greatest common factor is 12, because you think about what are the factors of 36, what are the factors of 48. The other option, if it doesn't come to you really quickly and easily, is to do a prime factorization. So you take 36 and break it down into two numbers that multiply to 36. So 36 is 6 times 6. And then break down the 6. That's 2 times 3. Those are both prime numbers. And the other 6 also breaks down into 2 times 3. So we can say that 36 is equal to 2 times 2 times 3 times 3. We just write them in order from lowest to highest. And then do the same thing with the 48. That's attached, okay. 48 we can break down into 6 times 8 is 48, right? 6 times 8. And then 8 is 2 times 4. 2 is prime. 4 is 2 times 2. And those are both prime. And 6 is 2 times 3. So we could say 48 is 2 times 2 times 2 times 2 times 3. Those are the prime factorizations of 36 and 48. And then to find the greatest common factor, you look for what's common in those two lists. They both have a 2. So we'll put down a 2. They both have another 2. So we'll put down another 2. And they both have a 3. So we'll put down a 3. 2 times 2 times 3 is equal to 12. So that's another way to find that greatest common factor. If you can't just kind of look at it and know, or write out the factors and figure it out, prime factorization is another way. So do the prime factorization and then look at what's common to both of them. And the reason that I want you to think about that method is because it's going to help us understand how to find the greatest common factor of polynomial terms. Just going to move all that other way so we can look at one of these other ones. Now we have these two, 16x squared and 24x. And I know that some of you can really easily look at that and know what the greatest common factor is. But I also know that for some people it's a little bit more difficult. So I'm going to take it fairly slow for these first two, looking for the greatest common factor. So I'm going to take 16 and break it down into a prime factorization. That's going to be my first step. So 16 is 4 times 4. And 4 is 2 times 2. And 2 times 2. So when we start looking at the prime factorization of 16x squared, it's going to be equal to 2 times 2 times 2 times 2. That's the 16 part. And then what would be the prime factorization of x squared? Do you know? What two things multiply together to give you x squared? X and x, right. So this is going to be then times x times x. That's the prime factorization of 16x squared. 2 times 2 times 2 times 2, because that's 16. And then x times x is x squared. When we do 24, so 24 is 4 times 6. 4 is 2 times 2. And 6 is 2 times 3. Those are all prime numbers. So then do 24x is 2 times 2 times 2 times 3 times x. Because it's just 24x. There's only one x term. To then find the greatest common factor, look at what's common in the 16x squared factorization and the 24x factorization. They both have a 2. So for the greatest common factor, I'm going to include a 2. And there's another 2 that they both have, so I'll include that too. And another 2. So we'll include that too. And then they also have an x in common. But that's it, right? Because we look at, there's still a 2 and an x that we didn't use from the 16x squared. And there's a 3 that we didn't use from the 24. But they're not common, so we can't use them. The greatest common factor is 2 times 2 times 2, which is 8, and then x. One last question here, looking at the greatest common factor. 3a squared b cubed. Well, 3 is already a prime number, right? So I don't even have to make like a factorization tree. I can just say 3a squared b cubed is equal to 3 times a times a times b times b times b. So I'm just splitting up however many a's there are and however many b's there are, and then the 3 is already prime. So a squared means I'm going to write down 2 a's. B cubed means I'm going to write down 3 b's. And then 6, well 6 is easy to do as well, a prime factorization of, right? Because 6 is just 2 times 3. So when we do that, 6a to the power of 4b squared, I'll do 2 times 3. And then how many a's am I going to write down? 4. And how many b's? 2. And the prime factorization is done a lot faster on that one. And so some of you might want to just kind of skip that tree part when the numbers are small and work it out that way. So now when I look at what's common, well, they both have a 3, and they both have 2 a's, and they both have 2 b's, which means the greatest common factor here is going to be 3a, b, b, or 3a squared, b squared. So now what we want to do with that is factor this polynomial. 6x squared y squared plus 18xy. And if you look over there on the right, the first step is find the greatest common factor of all the terms in the polynomial. What some of you will start to do is look at those numbers 6 and 18 and just think about their factors, especially if they're numbers that have relatively few factors. 6 is 1 times 6 or 2 times 3. 18 is 1 times 18, 2 times 9, and 3 times 6. So if you think about all those numbers, all those factors, what's the common number factor here? 6, right? It's the greatest common number that's a factor. So we'll start with 6. I'm just going to write the greatest common factor over here. So if you didn't do the whole prime factorization, that's okay. You can still come up with 6. And then x squared y squared breaks down to x, y, y. And the 18xy has just an x and a y. So the common thing there is x and y. So 6xy is the greatest common factor. Some of you will do that faster and some will take a little bit longer, and that's okay. But you need to be able to come up with 6xy. Now if we take this polynomial and look at the second step, write the greatest common factor and open a bracket. So all I'm going to do is go this equals 6xy, and then I'm going to open up a bracket. So an open bracket there, because I'm going to write some other stuff in there. That step's easy. Once you find the greatest common factor, just write it down. Open a bracket. The third step, this is what we did yesterday. Divide each term by the greatest common factor and write the quotients in the brackets. So we're going to do 6x squared y squared divided by 6xy. Like I said, that's what you did yesterday. So what is 6x squared y squared divided by 6xy? xy, right. 6 divided by 6 is 1. and then subtract the exponents. And then because there's a plus here, I'm going to write a plus here. And then we'll do 18xy divided by 6xy, which is 3. And that's it. That's factoring. What factoring is taking an expression and breaking it down into different things that will multiply together to give you that expression. So 6xy multiplied by xy plus 3 equals what we started with, 6x squared y squared plus 18xy. We're taking that polynomial and breaking it down into two things that will multiply together to give you that. That's what factoring means. All right, so greatest common factor here is going to be negative 5 CD. It's
Oh, I need to make an announcement. Do you mind?
yes, I mind. I'm recording my lesson right now. So now that Miss Tom's is finished, we'll go back to this. What I think I was saying before she interrupted was that negative 20 c to the fourth d is the first term. Because it's negative, we're going to make the common factor negative. Anytime that your first term is negative, make the greatest common factor negative. Because it doesn't matter, like the fact that it's negative doesn't affect whether it can divide something or not. But it's just going to look nicer if we don't have a negative first thing inside the bracket. That's why we do it. But just remember that if it's positive in the beginning, make the greatest common factor positive. If it's negative, make it negative. And then we have to divide all three terms by that common factor. So negative 20 divided by negative 5 is 4. And then we have the c's, c to the fourth divided by c. So c cubed. And then d divided by d, which means the d's gone from that term. Now we have negative 30 divided by negative 5. So it's a plus, right? It's positive 6 c squared d. Because we subtract, right? C to the power of 3 divided by c. That's 3 minus 1 leaves us with 2. And d squared divided by d. 2 minus 1 leaves us with 1d. And then negative 25 divided by 5 is positive 5. The c is gone. And we still have one of the d's left. And that's the answer. Let's do this last one. We'll do it together fairly quickly. 8 and 4 have a common factor of? 4. Oh, also of 2, right? But we want the greatest common factor. So we're going to choose 4.
4, 1a and 1
A squared and a.
So a and a.
So a. And then b cubed and b have b in common. You'll get to the point where you can figure that out without writing out the whole factorization. If you're not there yet, that's okay. Just take a few more minutes to figure it out. But then we divide. So 8 divided by 4 is 2. And I still have an a and a b squared plus 1, right. So when the common factor is actually one of the terms, make sure you replace that term with a 1. Don't just leave it as 2a squared b, yet you need the plus 1 there, so that when you multiply that out, you get what you started with. If I do the multiplication for ab times 2ab squared plus 1, this is just kind of a quick way to check. Multiply that. That gives me 8a squared b cubed. That gives me 4ab, which is the same as what we started with, which tells me that my factorization, which is right here, is correct.